Alright guys, paper 2. This video is going to be all about mistakes that you really do not want to be making in your paper 2, okay? AQA A-level chemistry. Now, a lot of this information is going to be taken straight out of the mark schemes, alright? AQA mark schemes. So if you don't want to watch this video, check out a mark scheme. I'll link it in the description down below. But I'm pretty sure a lot of you guys just scroll through that part and get to the actual mark scheme. So I'm going to break it down for you guys right here. Feel free to watch it on 2x speed or something just to get some tips so you don't lose silly marks when paper 2 comes around, okay? Right, so first off, we've got calculations. Now, the calculations you're going to be doing in paper 2 is going to primarily be rate equations. Then you're going to be getting some KC, chemical equilibria, or those equilibrium mole calculations, KC expressions, stuff like that. And you're also going to get amount of substance thrown in randomly, okay? That can come up. So the first point here is you will get full marks for the correct answer unless the question specifically says show your working or justify your answer. So some of you guys that are really advanced with maths or just aren't in the habit of showing your working, you're going to get all 5 marks for a typical calculation question, for example, unless it says show your working, justify your answer, okay? Keep that in mind the best you can. Next up, I'm going to give you a tip here. Try and keep your answer to the lowest number of significant figures given in the data. All right, this is really important for AQA. They're quite strict with this, okay? So for example, if throughout the data you're given a bunch of 2 significant figure values and then a random 3 significant figure value, always use the lowest number of significant figures given in your final answer, okay? When you're doing your actual calculations, try not to round it down to the lowest to begin with when you're doing your stages of calculation because you're going to use some rounding errors and stuff like that. So try and avoid that. But in your final answer, stick with the lowest possible, okay? Unless they specifically say, give your answer to 3 sig figs or something along those lines, all right? So always show it to the lowest significant figures of the data given, whether that's a data table, a graph, or just variables in a question, unless they specifically state otherwise, okay? Now, going back to my first point here, but changing it up slightly, even if you're confident with your maths ability, on the day you can still make silly mistakes, all right? So I would personally suggest always show your working, regardless of your maths ability, because even if you get the wrong answer, let's say it's a 3, 4, 5 mark question, if you get the wrong answer at the end or you don't show it to the correct number of sig figs, you will get marking along the way for your steps of calculations, okay? So just keep that in mind. Do the best you can. I'm sure if you guys do maths, you'll be well familiar with this concept, but just do your best to show your working, okay? That would be my advice right there. Right, reagents. So this is going to be for like things like organic synthesis, mechanisms, reactions, stuff like that, okay? If you see the command word identify, you can choose to either give the full name or the formula of the reagent. Okay, so for example, HCl, good old HCl, or you can write it out in full as the actual name of the chemical, hydrochloric acid. Okay, this is just an example. It depends on the mechanism, stuff like that, right? The main thing to remember here is that with reagents, it has to be something that is a specific chemical. Okay, name something that you can literally just take out of a bottle or a container. This is straight from the mark scheme, okay? So failure to give the full name will be penalized and you will receive 0 marks for that part of the question. Okay, so for example, if we're writing a reagent for a mechanism, for example, like a nucleophilic substitution or something, and you simply put Cn- or cyanide ion as your reagent, you will not gain any marks, okay? Even though technically this is the nucleophile, and you're thinking, yeah, easy question, mate, Cn-, you will not get the marks. You need to write the actual chemical name. For example, KCN for potassium cyanide, okay? Either of these is fine, okay? Either write the formula or the name, you'll be good to go. Okay, another example here, hydroxide, very typical nucleophile. Don't put OH- or hydroxide ion. You would need to write the full name, for example, sodium hydroxide or sodium hydroxide of the actual chemical. Okay, so that's a chemical right here. Just remember that for reagents, write the full chemical name that would come out of a bottle or container or something like that. Okay, these are just 2 examples here. Right, next up, drawing structures. Okay, first off here, displayed formula. Okay, hopefully you guys are well familiar with what this is. You simply just have to show all the bonds. All right, so a methyl would be like this. showing every single bond and then carrying on the alkyl carbon chain, chucking a cheeky bromide there, something like this. All right, I'm not going to spend any more time on this, but hopefully you guys know what display formula are. All good to go there. Let's rub this out. Next up, skeletal, okay? You must show all of the functional groups excluding the alkyl chain. So what do I mean by this? So for example, the way I always like to remember it is the alkyl chain, so the hydrocarbon chain is just a zigzag. That's just how I remember it. So for example, this would be pentane, right? So 1, 2, 3, 4, 5. 5 carbons, cool. So that would be how I do it. I'd do my zigzag, and then any functional group that is branched off of the molecule, I would do it as up and down like this, wherever that may be. Okay, so for example, chucking a bromide here, chucking an NH2 here, whatever's going on, could be completely random depending on the molecule itself, but that's how I would draw it. I think it's pretty easy, to be honest. Now, obviously, on each of these carbons, you have 2 hydrogens coming off. Okay, so for example, this would be a CH2 right here. You're going to have 2 hydrogens coming off of this. Don't need to show that. Okay, so that's what I meant by show all functional groups, excluding the alkyl chain. You don't need to show the hydrogens coming off here. Okay, so that's exactly my point right here. The carbon and hydrogen that are part or within the skeletal chain, and hydrogen atoms that are part of specific functional groups, for example, aldehydes, secondary amines, N-substituted amines, do not need to be shown. So just keep that in mind. You may want to show them. You would still get the marks here, but they do not need to be shown. So for example, here, they must be shown to get the marks, but these specific examples you do not need to show. Okay, so let's go for a quick example. For example, an aldehyde, right? What is that? As a H and an O at the end of the chain. So we've got our carbonyl group. You can just show that like this. Okay, you do not need to show the hydrogen as well. You can just show the oxygen. But if you're a bit worried, you can also show the hydrogen. That's completely fine. You'll still get the mark, but just keep that in mind. They do not penalize if you're missing hydrogens in these specific functional groups. Okay. Now, really keep this in mind. Let's say you did this, right? This right here, but you didn't show the hydrogen. This is now a ketone, okay? Keep that in mind. It's a ketone because this end of the skeletal formula is representing, what is it representing? CH3, okay? So don't make this mistake. It might just be easier for you to leave the hydrogens in, okay? Just to be honest. But if you're confident with skeletal, go ahead. All right, next part of drawing structures here. If you're writing out the structural formula for a specific molecule that's been asked, they cannot be ambiguous, okay? They can't be unclear. So for example, right here, 1-bromobutane must not be written as the molecular formula. So for example, this C4H9Br, this is the molecular formula for this guy right here, okay? You can't do that. It has to be written out in full with all of our alkyl groups, okay? Why is this? It's due to the presence of potential isomers occurring, okay? So for example, this one right here might have 2 isomers existing. So for example, like 2-bromobutane, something like that. In which instance, it would have the same molecular formula, and AQA doesn't really understand or know whether you're doing the right thing or not. So you have to write out in full like this. Okay, just an example here. Hopefully you guys are fine with that. Oh, this is where we're going to get into actually drawing the specific bonds between different atoms, okay? In the mark scheme, this is what it says. Bonds should be drawn between the correct atoms. Okay, and they have very strict rules with this. So I'm going to go through some examples after this slide of what you need to do and things you should look out for not doing. Okay, now all functional groups that contain a carbon atom, for example, carboxylic acids, aldehydes, nitriles, should show the bond coming from the carbon. All right, so let's say you're drawing out a structure in a mechanism. You want to show, let's say we've got our central carbon here, whatever carbon is within the chain. You want to draw your nitrile like this, okay? You don't want to draw it from the nitrogen, so like this. Just keep that in mind. The same applies to alcohol groups, okay? If you're showing a bond between the C and the OH, you need to do it bonded onto the oxygen part of the hydroxyl in the alcohol, okay? You cannot do CHO. This will be penalized on every occasion and you will lose the marks. All right, this is some interesting stuff that you should keep in mind here because it is accepted. So if you make a mistake, it's completely fine. So for example, right, methyl CH3 and amine NH2, you can show the bond to the carbon from the hydrogen. Okay, so for example, I've written it out here for you, but normally in my videos, I'll do something like CH3 or H3C, sorry, at the end of the chain. I'll draw it backwards to signify the bond coming from the carbon. okay? But you don't have to do this, and the same applies to amine NH2, okay? You can simply just do CH3 and do it on there to the carbon like this, okay? That will not be penalized, that's completely fine. But what they do say in the mark scheme is that these formats are preferred. Not gonna lie to you guys, if it's preferred, it doesn't really matter whether you hurt AQA's feelings or not, as long as you get the marks at the end of the day, that's what counts, and these is completely fine, okay? Same for NH2, not too complicated, all right? With things like this, so CH2 group, if you show the bond between the carbon and the hydrogen, you cannot do it like this, okay? So you can't do CH2. If you're just showing one of the bonds, this is incorrect. It's not bonded onto a diatomic hydrogen. Okay, that is incorrect. So if you're showing it onto two things, you want to make sure that you show both of the bonds here if you're doing it like this. Similar to displayed, okay? What you're trying to sort of skip steps, but you're doing things incorrectly. All right, so let's look at some allowed structures. If you want to check out the mark scheme again, it's written in detail in there, but feel free to watch the video. I'm going to go through them for you. Mainly just the primary examples, okay? So I've already said that this is allowed, CH3C. Obviously, there's bonds coming off of the carbon, but it doesn't matter whether you draw this backwards as H3C or if you just do it as CH3. Okay, this is completely fine. Another thing to keep in mind is they also accept this, which doesn't make sense to me, but they accept this, okay? Even though they specifically outlined that the carbon-carbon bond should be on the carbon, when it's methyls, they allow it on the hydrogen. But try and avoid this, guys. Try and do it on the carbon, okay? Now, a thing to keep in mind here, let's say you're drawing an ethyl side chain. So let's say we have a carbon here, and you're like, okay, I'm going to draw a CH2-CH3 group. You cannot do that backwards. Because obviously, this is on the end of the chain. You want that to be here. You want to switch these around, okay? So it has to be CH2-CH3. If you draw it like this, you will lose the marks, okay? Going back to alcohols again, this will not be accepted. You will lose the mark here. Same for if it's above or below the carbon. You're going to lose the mark as long as the hydroxyl is bonded onto the hydrogen. That is not accepted. Okay. Now, amines are accepted in the exact same format as this. Okay. So if we rub this out, rub the carbons out. Let's change this to be H2 right here. If you draw it like this or like this, both accepted. Okay. Try and get into the habit of drawing it on the nitrogen if it's not on the left-hand side of the molecule, just to be safe, and also it's just better practice, to be honest. Now, nitriles I've already kind of mentioned, but let's go through this. So let's swap these out for a nitrile here. You always want to do the nitrile, so it's like this, okay? Because it's a functional group that contains a carbon, they're very, very strict with this. Same with carboxylic acid, so you don't want to do this. Okay, don't want to do that. Okay, that is on the nitrogen, not the carbon, and you will lose the marks. So let's look at another example where the functional group contains a carbon. Let's look at carboxylic acids. Okay, this is another one. So you want to draw it so it's like this. Okay, Q, or you can draw it in full like this. That's completely fine. But you do not want to show the carbon bonded onto the hydrogen. All right, just keep that in mind. So for example, let's say you're doing it on the left. This is normally the instance where you're drawing it on the left, okay? And things should be mirrored really, but let's move this over. So right here, obviously, you're not gonna want to write Q because that is showing the functional group containing a carbon bonded onto the hydrogen instead of the carbon, okay? They do not like this at all. Same goes for if you're doing it below like this. Okay, big fat red cross there, you will not gain the mark. So they allow it for methyl, they allow it for amine, but they do not allow it for nitrile or carboxylic acid, okay? Same for aldehydes. So let's look at aldehyde quickly. CHO, good old CHO right here. This would not be allowed, okay? It would be like this. This is an aldehyde, okay? Or if you want to write it out as a formula, CHO, okay? Try and draw it if it's all possible, but that is what you want to do, not showing it bonded to the oxygen. This is not accepted. You will lose the marks, okay? So same for the bottom, same for the top. It doesn't really matter. Make sure you show it on the carbon for these functional groups that contain a carbon. Okay, same for acyl chlorides, guys. Any of these functional groups that contain a carbon, you want to show it on the carbon itself. So this would be correct, right? COCl. You do not want to show it like this, COCl. Or if we do it on the left right here, it's COCl. Okay, try and avoid this the best you can. You will lose the marks. With these functional groups, I like to draw them out in full, to be honest, to avoid these sort of mistakes. So it'd be like this. But yeah, just keep that in mind. Right, let's look at some aromatics real quick in terms of what is accepted and what isn't when you're drawing those substituent groups on the benzene molecule. So let's draw out our good old benzene right here. Now, you're going to be having this a lot of the time where you're drawing side groups off of this. Depending on what's going on, let's say we're drawing this. What would be accepted? NH2, completely fine. For an amine, okay. When we're dealing with nitronium, this is completely fine. NO2, okay. What is not allowed is, let's say you're drawing the side group on the left-hand side of the molecule and you're tempted to do this. Don't do that. You will lose the marks, okay. Big fat red cross right there. You want to do it backwards, so it would be O2N like this. NO2, okay. Bit weird looking at that, but that's how it would be. I would advise just sticking things on the right like this. One of these three would be good. Obviously, with a benzene, you can turn it and twist it. So it should be completely fine unless they tell you the specific carbon that group is bonded on. Try and stick it like this on the right-hand side of the molecule and it makes it a bit easier for you. Now, again, very similar to example, when you're dealing with an amine bonding onto a carbon, you can do the exact same thing here, okay? So NH2 like this, if it's on the left-hand side of the molecule instead of the right, this is accepted, okay? So you'd get a mark here, but ideally you want to try and remember the whole like backwards thing when they're on the left to signify the actual atom that is bonded on, but the NH2 is accepted, okay? So just keep that in mind. Another weird thing is, this is also accepted like this, okay? So there's, for AQA, for whatever reason, they allow certain weird rules, like this is allowed, but in other instances, things aren't allowed. So if I was you, in your shoes personally, which I have been in the past, I would just get used to the fact of bonding the correct atom on, okay? I would just try and stick with that. That would be my strict rule, and then you can't really go wrong, to be honest. So yeah. All right, one real quick one to do with alkenes, okay? So let's say we have good old ethene, right? Normally you're going to be trying to draw this out like this. If you're doing some sort of mechanism or some sort of alkene that has a mechanism going on, for example, electrophilic substitution. But let's say you're writing out the structural formula, right? So you do CH2 double bond CH2. This is accepted, okay? You can also do it in the correct format of H2C double bond CH2. Because this is on the left-hand side, you have to show where the bond is actually on, but this is accepted as well. Okay, so just keep that in mind. Now, another thing they allow is for alcohols. So let's say we have propan-2-ol, right? And the reason that you don't want to show the molecular formula, why was that? Isomers, right? So let's draw out CH3, CH, OH, CH3, okay? Propan-2-ol, it's in the second carbon position, right? Now, you're going to see this sometimes with brackets around it, signifying that it's branched off of this carbon right here, okay? But you don't need to show the brackets. Either of these are accepted, okay? They gain the marks, so you're all good there. All right, mechanisms. I've done a long-ass video on mechanisms. Hopefully you guys have checked that out. But for this video, I'm just going to go over the common mistakes that you do want to avoid, okay? So what is a double arrow? What does this show us? It shows us the forming or breaking of a covalent bond, right? The movement of a pair of electrons. So you always want to show in your mechanisms the double-headed arrow coming from the lone pair if it's being donated to something. So for example, like a nucleophile, or you want to show it from the bond going on to something else. So in my mechanism video, I just gave the example of an X right here for any sort of atom or ion or whatever's going on. That is how you want to draw it, okay? So for example, let's say we have a hydroxyl right here, right? You do not want to show the curly arrow coming from the oxygen. Even though the oxygen is technically the electron donor within this hydroxyl group, you do not want to show it there. You all just try your best to remember, you show the double-headed arrow from the lone pair and you should not lose the marks. Another thing to say is that I always try my best to show where the negative charge is on the correct ion. So for example, the negative charge is on the oxygen here. So I will normally draw it to the side of the oxygen, right? I normally just stick it to wherever the lone pair is. But if you draw it like this, OH minus, completely fine. Same with a nitrile, right? Completely fine. Okay, just remember that. And obviously you don't, they show this in the marks game. I'm not sure why someone would do it, but you don't want to show the double-headed arrow coming from the negative charge. They give it as an example of things that aren't accepted, but yeah, just keep that in mind. Another thing is, For whatever reason, I don't know why, but some people show the 2 electrons, right, in the covalent bond. Even if you draw the arrow from the bond like this, breaking, but you include the lone pair, sorry, not the lone pair, the covalently bonded pair on this bond right here. So for example, if it's like a carbon bromide bond, you will lose the marks. So even though technically you're drawing the curly arrow from the bond, because of the fact that you showed the pair of electrons in that covalent bond, you lose the mark, okay? Same thing for if you try and show a dipole. So for example, delta negative, delta positive, you should get in the habit of drawing these and understanding it. But let's say you draw the electrons over here, signifying that they are drawn towards the more electronegative atom, you're going to lose the marks, okay? So don't draw the electrons on the bond. That would be my main takeaway from that. So I'm going to do a real quick example of nucleophilic substitution, okay, as a quick example of what would not be accepted and you would just straight up lose all the marks, all right? So let's say we have a halogenyl alkane. I'm just going to do a real easy one right here. Bromoethane, sorry, CH3HBr. Cool. So what's going to happen here is obviously there's delta positive, delta negative. We're going to have, I'm going to use our hydroxyl as our example, going to go from the lone pair onto this delta positive carbon. All right, that would be correct. But what you don't want to do is something like this, going from the O, or something like this, going from the lone pair, or going from the hydrogen. You don't want to do that. Always show it from the lone pair onto this carbon, okay? Another thing, don't do this. Don't show it going onto the bond. You won't get the marks, okay? Next up, when we're dealing with the leaving group, so in this instance, it's the bromine, you always want to show it from the bond, okay? That's where the electrons are coming from. You don't want to do it from the carbon, okay? This would be crosses all over the place, okay? Try and avoid mistakes like this, and you should be completely fine. All right, let's quickly go over free radical substitution where you'll lose marks, all right? So let's say, obviously, you've got something like this, right? 2 free radicals showing the free radical as a single electron or a single dot. Okay, that's how you want to show it. Now, if you leave this off, let's say you do a bunch of equations, you do an initiation, propagation equation or something like that, right? Termination, and you leave off the free radical, this will only be penalized once. Okay, but hopefully you guys can put that on there in the correct place and you know your free radical substitution equations, but if not, it will only be penalized once. One more thing about mechanisms, let's say you're in the habit of doing skeletal formulae, right? So our pentane example, if a mechanism involves a carbon-hydrogen bond, so for example, one of these carbon-hydrogen bonds right here, if you draw the mechanism where the carbon-hydrogen bond is involved in some way, so it breaks off and is lost from the starting molecule, but you do not show this bond, you will lose the mark, okay? You must draw the bond and whatever's happening to gain the mark, okay? Just keep that in mind. All right, nomenclature. Now, there is a lot to do with nomenclature, and it's honest, this isn't a nomenclature video, okay? There is way too much to go through, but I'm gonna give you 2 steps of tips that I just think are super, super, super helpful. Some of you may not be aware of this, okay? I learned this from Chemrevise, so if you don't use Chemrevise, check it out. The first thing I'm gonna go through is the order of priority. Okay, so when you're naming your organic molecules, you obviously want the priority, the highest priority, to be the suffix. Okay, so you have your prefix, and then whatever is going on, and then your suffix. Okay, with various number rules and stuff like that, depending on the functional group. I'm not going to go through that. I'm just going to go through the priority and some tips when it comes on to naming. Okay, so what is our priority? Carboxylic acid, I'm going to draw these out as the functional group. This is our highest priority molecule. If it's present in something, it will always be the suffix. Okay, it will always be the suffix. It is the highest priority. That's just how this works. If something is the highest priority, it will be the suffix in the name. Do your best to remember that. Now, the next thing is going to be carboxylic acid derivatives. Okay, and the way I'm going to draw this out is this is greater than this, which is greater than this, which is, okay, so it's going to go from highest priority to lowest in the chain, in the sequence right here. Okay, so the next thing is Q derivatives. Okay, what does that mean? So let's go for some examples. Ester. Okay, acyl chloride. Acid anhydride, you get the idea. Any sort of carboxylic acid derivative, that would be our next priority group, okay? Then what do we have here after that? We have nitriles. Okay, nitrile. Okay, what is after that? Aldehydes. Okay, aldehydes and ketones. Let's do it. I'm going to carry it on down here, but remember it's going from left to right. So I'm just going to run out of space, but it's carrying on in the same sequence. Aldehydes, and straight after aldehydes is ketones. Okay, aldehydes have a greater priority than ketones. Try and remember that. Next up is alcohols. Okay, these carbonyl groups are going to have a much higher priority than alcohols. So let's put that here. Alcohols. Next up, we're going to have amines. Okay, amines surprisingly quite a low priority. Amines, cool. What's after amines? Alkenes. All right, alkenes. Last one here, after alkenes, the lowest priority, haloalkanes or halogenoalkanes. Okay, this is all one word, but I had to slot it down because no space. But yeah, try your best to remember this sequence of priority and you'll be all good to go for naming molecules, okay? Also remember that the higher the priority, the lower the carbon within the alkyl chain that functional group takes. For example, let's say we were comparing a carboxylic acid and an alkene, just two random functional groups here, it doesn't matter, or an alcohol, whatever it may be, the higher priority will be on the lowest carbon when you're naming it, okay? So just keep that in mind. All right, next up, 2 rules. Really try and remember this. This came from Chemrevise, so feel free to check that out. I'll link it in the description down below. But this saved me so much in my exams, okay? These 2 rules right here regarding IUPAC naming to do with the suffix, okay? So when you're naming a molecule, right, you're going to be naming the number of carbons within the alkyl chain. So for example, propan, okay? Well, let's write it out in full. Propane, okay? How many carbons is this? 3. So when you're naming a molecule, so for example, let's use an example of propane 1-ol. Now this is incorrect, okay? This is an alcohol on position 1 of a propane carbon chain, okay? This is incorrectly drawn, I'm just using it as an example. Now, the rule is, let's draw this out. Do your best to remember this. If the suffix starts with a vowel, okay, what is a vowel? A, E, I, O, U. If the suffix starts with one of these letters as a vowel, you can remove the E from the alkyl chain. So let's write that out. Remove the E from alkyl chain. Okay, so let's look at some examples. Let's go back to our propane 1-ol. What is the starting letter of our suffix? Our alcohol group is a vowel. All good to go there. So we're going to get rid of the E, right? So it's going to be propan 1-ol. Okay, let's look at another example, okay? Let's look at an amine. Let me get rid of this 2 right here and just focus on this rule for now. So let's look at an amine, okay? So amine is going to be our suffix. In this example, depending on the priority, this may change. But in this example, I'm going to just focus on one functional group being present as an amine. So again, I'm going to write out our number of carbons. Okay, butane. What position is that on? Let me actually rub this suffix out quickly. It's going to be on position 2 in this example. So this would be our name right here, butane 2-amine. Now I'm going to use the rule that I just went through. Does our suffix start with a vowel? Yes, it does. So we get rid of the E in the prefix, okay, or in the alkyl chain. So that's what I'm going to do. Get rid of the E. Oh, my robot got rid of everything. But that is what you want to do. You want to look at the suffix. Is there a vowel as the first letter? If there is, you get rid of the E in the alkyl chain, okay? Okay, so rule 2, if the suffix starts with a consonant, what is a consonant? Anything that's not these guys right here. Or if there are more than 2 of a specific functional group present. Then you must include the E. I'm going to write that in blue. Then include E in alkyl chain. Okay. Right, so let's look at some examples so you're not confused what I'm talking about. If there's two or more of a functional group, so two of the same functional groups you would put as di. Okay, so for example, diol would be two alcohols within the same molecule, right? Or triol would be three. Triol. Three hydroxyl groups in a molecule, okay? Simple as that. Now, if that is the case, if there are two or more of the same functional group present, or if it starts with a consonant, you will need to add the E. So let's look at an example of a consonant being present. So let's use an example of propane nitrile. Okay, cool. So suffix right here is nitrile. First letter. Does that start with a vowel or does it start with a consonant? It's a consonant, okay? So you want to include the E. So a little tip here, guys. This is pretty much the only functional group that's going to start with a consonant. So if you can remember nitrile, it would do yourself a favor, okay? Next up, let's look at some examples of di and tri functional groups being present, okay? So let's go for pentane dioic acid. Okay, now don't think that in this instance, because the suffix is a carboxylic acid, it's oic acid, therefore the start of the suffix is a vowel, so you get rid of the E, okay? That doesn't take place here when you're dealing with two or more of the same functional groups with the stem name di or tri, okay? In this instance, the di or the tri is going to be the start of the suffix. So this is a consonant, not a vowel, so we have to include the E. Okay, so let's go for a try this time, okay? So let's look at butane. I'm going to put the position of the hydroxyl groups here. So 1, 2, 3 is just going to be my example. And then the end of the name, the suffix is going to be triol. Okay, 3 hydroxyl groups. So it's a triol present, so we keep the E. Okay, simple as that, guys. Do your best to remember these, and it should make naming molecules in the IUPAC system a hell of a lot more easier for you. Hopefully you guys found this video helpful. Best of luck with paper 2, guys. All the best in your revision and upcoming exams. Until next time, peace.